Hi students, welcome back. Today we are going to solve the sort colors problem on lead code. Okay, let's look at the problem statement first. So the problem statement says we are given an array nums with n objects colored red, white or blue. Sort them in place so that the objects of the same color are adjacent with the colors in the order red, white and blue. We will use integers 0, 1, 2 to represent the colors red, white, and blue respectively. You must solve this problem without using the library's sort function. So essentially, what they are saying is there are three types of values in an array: red, white, and blue, represented by numbers 0 and 1 and 2, and they are jumbled in the array. We have to sort them. Okay, and we have to sort you without using the inbuilt sort functions. Okay, so let's look at the examples. So the first example, the numbers are jumbled like this. Once you sort it, all zeros comes first, then ones and then twos. Similarly, zeros, ones and twos. Okay, then let's see how we can implement this. Let's take this example. Okay, here the array we have is has nine numbers which has 0, 1, 2 respectively. So one naive implementation that we can think of is just use any sorting algorithm. Okay. So if you use any sorting algorithm, let's say merge sort or anything, okay, we will be able to solve this in order of n log n complexity. Okay. But that means we are not using any of the given properties. Like the given properties say there are only three types of numbers possible, and we are not using that property. Okay, so an improvement can be, so if you use the regular sort, the best we can do is order of n log n. Nothing else is possible. But if you just use this attribute that there are only three types of numbers possible, we can use something called a counting sort. Okay. In counting sort, what we will do is, let's say we know that there are three types of numbers, right? So we maintain three counts: count zero, count of ones, and count of twos. So in this example, there are three zeros, three ones, and three twos. So we will do the counting in one pass, and in the second pass, using these counts, we will just build the array. For example, for count 0 to count of 0, we will fill the array with zeros, followed by count ones, followed by count twos. Okay, so this will give the solution. So we will do two order of n passes here. So it would be order of n space complexity. But there is a better solution, and we can do this in a single pass in order of n. So let's look at that solution. You can try the counting sort implementation yourself. Okay, so let's see how our algorithm looks like. So in this, what we will do is the objective is to first form zeros, then ones, and then twos, right? So if you just push all the zeros to the start and all the twos to the end, then you'll have ones in between and the array will be sorted. That is the uh, funda we are going to use. Okay, let's say we have a start pointer here. Okay, and we have end here. Okay, we will use one pointer to keep track of the index. Okay, so initially when we start, we have index at 0. Okay, start at 0 and end at size of array minus 1, which is 8. Okay, this is where we are. Now, what we will do is, if nums of index is equal to 2, that means we have to push the value to the end. So here, start and end, what they are holding is the probable position for the next 0. Okay. So if nums of index is 2, what we will do is we will swap, okay, nums of index with end, whatever is there at the end, which is nums of end. Okay, we will do a swap and we will do end minus minus, meaning we have to go to the next probable position for 2. Okay, so here when we start index, nums of index is 0, it's not 2. Okay, let's write the other case as well. What happens when nums of index is equal to 0? Okay, that means we found a 0, we have to move to the zeros position, which is start. Okay, so we swap nums of index with nums of start. Okay, and we increment start. Okay, in this case we will also increment index because we are moving from the start of the array. Okay, we are moving from front to back. We have already seen what is there at the swapped value, which is why we can increment the index as well. Whereas in case of end, we have not seen what is there at the end. So we cannot increment the index in that case. Okay, so this is a simple algorithm. If it is equal to 1, we just increment start, nothing else. Okay, so let's run through this with this example. So initially when we started, start is 0, index is 0. So based on our uh, case here, we have to swap index and start and increment start and index. So when you swap the same number, you won't get anything new. It's just the same value, but we will increment start and end. So start will move here, okay, and index also will move here. Okay, now at index we have value 1. Okay, so when it is value 1, we just increment the index. We don't have to do anything. So index will just go here. Okay, now the value at index is 2, which means we are in this case. Okay, we have to swap it with end. So when you swap 2 and 2, both are same, so you won't visibly see anything different, but end will be decremented. Okay, so end will move here. Okay, and end becomes 7. Okay, now we didn't increment the index, which is why we will process the swap 2 again. See, this is the reason why we don't increment the index. We haven't seen this 2, so we have to process it again. Now, again, the current value is 2, so we swap with end. So, end moves here and end becomes 6. Okay, and the values are swapped, right? So this becomes a 0 and this becomes a 2. Okay, now the current value is 0. So what do we do now? We swap it with start, which is, so this becomes 0 and this becomes 1. Okay, and we increment both start and index. Okay, so both start and index go to their next position. So start goes here, index goes here. Okay, now what is the value at index? It is 0. So we again swap with start. Okay, so what is there at start? 1. So this becomes 1 and the start value becomes 0. Okay, and we again increment both start and index. Okay, start comes here and index comes here. Now we have 1 at index. We don't have to do anything. We just increment to the next value. Okay. Even in the next value, we have 1. So we go to the next position. Okay. So we come here. Now we have 2. So we have to swap it with whatever is there at the end. So end is also in the same position. So you don't have to do anything. And end becomes end minus minus. Okay. So end comes here. Okay. Now we have gone beyond the end. That means the array is already sorted. So if you see the resultant array here, we have 0. We have the new swapped value 0 here. 0, 1, 1, 1, 2, 2, 2. So the array is sorted. Okay. So the algorithm is pretty simple. You keep 2 pointers for the next probable position of 0 and 2, and you keep swapping 0 and 2. Since there are only 3 values remaining in the array, the remaining values would be in the middle and they will be 1. Okay. So let's try and write code for this. Okay. So we need 3 variables. One is start to keep track of zeros. One is end to keep track of twos. Okay. And we have something called current index. Since we are going from front to backs, the current index will be 0. So as long as the index is less than or equal to end, okay. Why are we doing less than or equal to? Because end is already nums dot length minus 1. Okay. And once end crosses index, that means beyond that everything is already 2 and we have seen them. So if we do it as long as index is less than or equal to end, that is enough. Okay. What we are saying is if nums of index, okay, is equal to 0. Okay. What do we do if it is 0? We swap nums at index and start. We will write this function. Okay. And we will increment index. We will also increment start. We are incrementing start because we have already seen the position value at the previous start. We don't have to see it again. Okay. Because we are going from front to back. Okay. Else if nums of index is equal to 2, okay, we have to swap it with the next probable position of 2, which is at the variable end. Okay. And we only do end minus minus. We don't do index plus plus because we haven't seen the variable value at the current end position. If we have to see it and take a decision again, which is why we won't increment the index in this case. And in the else, when it is 1, you don't have much to do. You just do index plus plus. This is a void function. We don't have to return anything. We just have to in place update the array. Okay, but we do have swap to be implemented. Let's implement that. Let's say in a given array, we have to swap at value set position m and n. Okay, nums of m. Okay, it's a simple swap. So now nums of n would be 10. Okay, this should swap. Let's submit them and see. Okay, so essentially what we are doing is we are pushing all the zeros to the front, all the twos to the end, and in the process, only ones are remaining and they are in the middle. That's all. Okay, so that's all for this video. Thank you for watching.